All right, everybody, so we're going to go ahead and get started here with 3.2.1, looking at the core problems. So we're going to be looking at these following problems. First off, 324 through 327, that's 4 problems, and then 330, 332, and 333. In your textbook, it's going to be 139 through 142 if you want the page numbers, but you will want to use your e-tool for this first problem here. All right, so first off, we're looking at subtracting today. More specifically, subtracting positive and negative numbers. So we're going to be using positive and negative tiles to help us visually represent the subtraction of integer problems. We're going to think about how we can remove negative tiles when the collection has only positive tiles, how we can subtract when there are not enough to take away, right? Because subtraction means to take away. And then finally, when does subtracting make the result larger? So here's our first problem, 324. We're going to click on this blue hyperlink to answer these questions. So I'm going to click right here, and it's going to take me to the page that looks like this. And my questions are still on the left side of my screen. So first off, it says, what happens if 3 positive tiles are removed? Well, let's go ahead and first off, take a look at what integer this assortment represents. All right, so I'm going to take my positive tiles and put them lined up down here. I'm going to take my negative tiles, put them right up above my positive tiles so I can do my 0 pairs. And right away, if I go ahead and cross out where I see my negative and positive tiles, I am left over with just -2 tiles. All right, so that's my original assortments here. So I'm going to start with -2 tiles and -2 tiles for part A and part B. All right, because that's what we're starting with originally. And now part A, which I'm going to do in this pink color, it says, what happens if 3 positive tiles are removed? All right, so I'm going to get rid of my markings here, and I'm going to take away 3 positive tiles from this group. We're going to see what happens. Now, when we're taking away, what operation are we doing when we're taking away? We're doing subtraction, right? So I know it's going to be subtracting. And here, are we subtracting a positive or a negative number if we're taking away 3 positives? Well, we're just simply taking away 3 positives. So it's going to be minus +3. And if I do -2 minus 3, +3, then that's going to leave us with -5. All right, now this time, again, we're starting with -2. We are going to subtract -3, and we're going to see if that changes our answer here. So I'm going to put my positive tiles back. So my original value is -2. And this time we are going to subtract -3. I'm going to do this problem in light green, problem B. So I'm going to take three negative tiles. So I'm going to do subtracting -3 this time. And I'm going to put them out of the picture. And so now if I cross out my 0 pairs, in other words, my positive and negatives, what am I left over with? Well, we see I have just this positive left over, 1 positive. And so -2 minus -3, that's going to equal 1. And we could also think about that in the same way when we watched our video where we could change this to -2 plus +3, right? You could change the signs for both the subtraction and the negative number to make it a positive statement, but we're not going to worry about that. So we just answered the 2 problems. We noticed that when we subtract +3 and then we subtract -3, we end up with different answers, and we just showed why that is with our diagram. So let's hop back to our problem set. We just answered 324. Now we're looking at 325. It says, it is often useful to represent operations and expressions in multiple ways. These ways include we have diagrams, expressions, and situation in words. So we are going to represent the following problems here in different ways. Now, first off, I'm going to take a look at problem A and say, okay, how can I write this as a numerical expression? That's what I'm focused on. And so here we're starting with 8 positive tiles. And if I look what our then statement says, it says we're taking away 2 negative tiles. So I know taking away means that we're going to be subtracting. And in this case, we are subtracting negative tiles. So we're subtracting negative. And that would leave me with my 8 positive tiles and my 2 other positive tiles. So it would equal positive 10. And if we want to think about this as an addition statement, it would read as 8 plus positive 2, right? You could change the sign here, but it wants it as a negative expression. So we're going to do 8 minus negative 2 gives us positive 10. All right, now we're looking at part B. It says negative 8 minus negative 3. Well, this time I'm going to start off by drawing the tiles. So I'm going to represent negative 8 here. 6, 7, 8. And we are going to take away or get rid of, I want to circle these 3 negative tiles and put them out of the picture. So now what am I left with? Well, here I have 1, 2, 3, 4 negative tiles still. So here, negative 8 minus negative 3 equals negative 5. And again, we could think about this as negative 8 plus positive 3 equals negative 5. Same thing. All right, now we're looking at problem C. It is cold. The first time I looked at the thermometer today, it said 0 degrees. Then it dropped 5 degrees. How cold is it now? So obviously this is something we're used to here in Wisconsin. So I want to do this one on a numbered diagram. So here we have 0 minus 5. What is that going to equal? Okay, so I have my number line here. I know we're going to be going in the negative direction, so I'm going to start at 0 and write some negatives afterwards. So here we're at 0, and we're going to be going in the negative direction, so this direction. And we're going a positive 5. So I know we're going to keep going in the negative direction. We're not going to do the opposite. So here we're going to negative 1, negative 2, negative 3, negative 4, negative 5. We're going to be going 1, 2, 3, 4, 5 in the negative direction. Puts us right here at negative 5. So 0 minus 5 equals negative 5. All right, now we're looking at 326. So it says we may want to review the math notes in 2.2.4. It's going to remind us how to use positive and negative tiles to represent integer addition. More specifically, the cancellation of positive and negative tiles. 0 pairs is what I have referred to them in the past as. And so here it says another useful strategy for finding 0 is to use positive and negative tiles. And the diagram at the right can be represented by the equation negative 1 plus 1 equals 0. So here, if we look over to the right corner of the screen, we see a positive and a negative tile. They would cancel out, and they would just equal 0. So we're going to use this idea for adding 2 integers. And you'll see what I mean here below. It says 5 plus negative 3, so we put 5 positive tiles, and then we put 3 negative tiles, and then we cross out the positives and the negatives, and here we're left over with negative 2. I'm sorry, positive 2, because we have 2 positive tiles, so that's where we get our positive 2 from. Same thing here, we start with negative 5 tiles, and then we add positive 2 tiles. These would cancel out. We're left with 3 negative tiles. So we're going to have -3 as our answer. All right. So we're going to use this idea to help us find these answers. This is A, C, and E. You guys are going to be solving for B, D, and F. So first off, let's do A together. I'm going to start with 7 positive tiles. So I'm going to grab my green here, and I'm going to do 1, 2, 3, 4, 5, 6, 7. And then I'm going to take away +5. So I'm going to take away these 5. Just get rid of them. Right? That is my -5 portion. And that's going to leave me with 2 positive tiles. So this equals 2. 2 positive tiles left. Now I'm looking at C. C is -6 minus 2. So I'm going to start with -6 here. And then to do this -2, well, let's think about how I could represent -2 while not changing the value. Well, I could add 1, 2, right, up top for my -2. But then I'd also have to add some positive tiles here. That way this here still equals 0. It doesn't change the value that I'm starting with. I'm still starting with -6. And then if I take away +2, okay, so I'm going to take away my positives here. So take away that one positive, taking away another positive. So I'm subtracting +2. Then what am I left with here? Let's go ahead and see what we're left with. We have 6 negatives, and then we have 2 more negatives. So -6 minus 2 is going to leave me with -8. All right, now we're looking at E. It says -8 minus -5. So I'm going to start off with drawing -8. Oh, somehow I turned on the subtitles. So we have -8. I'm going to represent that here. 1, 2, 3, 4, 5, 6, 7, 8. And now we are going to take away, because it says subtract, -5. So here I'm going to take away -5. So I'm going to take away these 5, subtract -5. And what am I left with here? I'll do this in orange. I'm left with 3 negatives. So -8 minus -5 is going to leave me with -3. And we can think about that as -8 plus +5. It's the same thing. And that's going to give us -3 as well. So just one way we can check our work. Moving on to the next problem set here. So subtraction can also be represented on the number line model. Sketch the number line above on your paper. How can you represent 2 minus 7 using the number line? So let's go ahead and start with +2. So we're going to be over here, and we're going to subtract +7. So I know that the subtraction sign tells me that I'm going to be going backwards. And since I'm going to be going backwards, +7 is going to be regular subtraction. 3, 4, 5, 6, 7. So I just moved back 7 spots, or +7 in the negative direction. Discuss your ideas with your team. So here we're going backwards and ending up at -5. and that's because we're doing normal subtraction here. Now we're looking at part C. It's a little bit different because now we're subtracting a negative number. So let's think about how that's going to impact our diagram and our answer. So here we're starting at positive 1. And it says we're going to subtract. Now, when I subtract, I know that I'm going to be turning around and going this direction. But notice, I am instead moving -2. I'm moving a negative number. And if I'm moving in the negative number on a number diagram, we are instead going to be moving in the opposite direction. Okay, that negative tells us to do the opposite. So instead of moving backwards, we're moving actually forwards, because subtracting a negative is the same thing as adding a positive. So we're going to move 1, 2, and here we end up at positive 3. Does that make sense? We would have normally just gone 2 backwards, but instead, since it's a -2, we're going to do the opposite, and we're going to move forward 2 and end up at positive 3. All right, now it says represent the distance between each pair of points below in 2 ways using the absolute value symbol. For example, the distance between 8 and 3 can be written as 8 minus 3 equals 5, or 3 minus 8 equals -5, but taking the absolute value of that would just be 5. So let's go ahead and start here with -2 and 1/6. And we're going to find the difference between that and the number 1. So I could start off by doing simply just subtract 1. So here we can think about it as we're at -2 and 1/6. We're going to just move 1 in the negative direction. So now we're at -3 and 1/6. But if we wanted to, we could also do 1 minus -2 and 1/6. And from here, we could change this to an addition problem, right? Change the signs, and this is now going to become 3 and 1/6. So now notice our answers are different in the sense that one's negative, one is positive. But if we take the absolute value, we're going to find that this would turn to 3 and 1/6, and this would remain 3 and 1/6. And so either way, we're going to be getting 3 and 1/6 when we look at the absolute value of the distance between -2 and 1/6 and 1. All right, now let's look at part C. So you guys will do B. We'll skip to C right now. This time we have 9 3/10. And we're going to be subtracting a negative here to start, -6.55. And when we're subtracting a negative number, we can think about that as adding a positive number. So here we're starting at 9 3/10. And then if we're moving 6 more in the negative direction, subtracting 6, in this case, just adding a positive. 9 plus 6 would give me 15. And then the 3/10 plus the 0.55. Well, 3/10 I know can be written as 0.3. So I'm going to add 0.55. And that's going to give me 15.85. And we could show this by also doing 9 3/10 minus -6.55. Now we're looking at 3.32. Add parentheses to make each subtraction equation true. So here, there's a little bit of a challenge. We have to figure out where the parentheses would go in this problem. We're looking at problem A to make the expression equal 0. And notice we have the same numbers in each of these expressions. They don't change. And so 1 minus 3 minus 5 minus 7. Well, if I just did that like all straight across, that's going to give me negative 14. So I know I have to definitely put some parentheses in here. Let's look for my 0 pairs. So let's see, if I did 1 minus 3, what did that give me? It's going to give me negative 2. And if I did 5 minus 7, that's going to also give me negative 2. But if I'm subtracting a negative, like we'd see here, that's the same thing as adding a positive. So I'm going to go ahead and switch that around. And that would give me 0. So this would work if I put parentheses here, and if I put parentheses here, because it's like negative 2 minus negative 2 does equal 0. And now your challenge is to put parentheses for C and D, because if we look at B, 1 minus 3 gives us negative 4, minus 5 gives us negative 9, minus 7, well, I guess that'll give us negative 16. So maybe we do need to put parentheses here. Can we put parentheses anywhere? Oh, this is kind of a tough one, isn't it? All right, so we'll spend some time there on that challenge. And then we're going to be looking at, finally, these main points. So how can we remove negative tiles when the collection has only positive tiles? How can we think about subtraction when there are not enough to take away? And when does subtracting make the results bigger? All right, so think about what we had to do when, say, we had like negative 6 minus negative 2. How did we show with these tiles that negative 2 without changing the original value of negative 6 to start? So like, how can we show taking away negative 2? If you guys remember, we had to put the positive tiles, and then from there we had to either take away the negatives or take away the positives, depending on what it was telling us to do. So when does subtracting make the results larger? That's the other question we have here. All right, so answer these questions down in your sheet, and that'll be it for your core problems. You'll be turning these in on Canvas. All right, thank you guys very much. I appreciate it.